Okay, continuing on the standard for polynomials, okay? I want you to tear up, or quietly take this first page off, because this is something we're going to constantly refer to, and I want to graph that function. Now, it doesn't make a line because there's exponents on the variable. It also will not make a parabola this time because you have a higher power than x to the second. Okay, the parabolas to use are for x to the seconds. Now this f parentheses x is just a funky way that they write y. I don't like it, but it's there. Okay, so what I need to do then is, with higher degrees than a 2, you need to make a table full of coordinates, okay? And you can go as far as you want with that. I'm going to start with -3, okay? And go down to +3. And then I'm going to insert those numbers into the equation. You don't have to use any magic formulas, okay? You kind of just have to grind it out with that. So I replace x with -3. To get the third power, you hit the caret button, 3, plus 7, parentheses, and then -3, close it, second power, minus 5, parentheses, -3, and then add 1. You get a very high value, 133, a very extreme value, I should say. Now I click the up key, and I replace the -3's all with -2's. Okay, click equals, we have 55. Okay. Click the up key, replace the -2's with -1's. 15. Now when x is 0, okay, you can just basically cover up all the x's and you have that constant of 1 at the end. So 1 is your y value. Now to go to positives, you have to put your cursor over the negative, click del. Okay, and now you're at 1, del, del, and I get 1. Okay, when I put 1 in for x, the whole y value comes out as 1. I know these are the same, which is kind of weird, but it's actually true. Okay. Then I click the cursor and I replace the 1's with 2's. Okay. Alright, I got 3. Then I click the cursor and replace the 2's with 3's. Okay, -5. Now plot those points. Now, this is pretty extreme, so I'm not going to graph that actually, okay? So -2, 55, I go left 2, and I'll go 10, 20, 30, I'll go by 10s on the y. 10, 20, 30, 40, 50, and then 55. Okay, -1, 15, okay? 10 and then 15. 0, 1, 0, 1, remember you're going by 10, so you got to go up just a little ways. 1, 1, I go right 1 and then right beside that. 2, 3, I go right 2, up 1, 2, 2. Okay, so 3 is going to be right here about. Okay, I did that right. And then 3, -5, 1, 2, 3, then -5's right there. Now you click that. This way you're going up, and this way you're going down. Okay. Now I got a little question. X approaches, you see this little sideways 8, 2 little circles. It means as x goes positive infinity, that means out that way, what does y happen? What happens to y? That arrow means it approaches. Well, that's just going down as I move out that way. So y approaches negative infinity. This is called the end behavior of the graph. Now as x approaches negative infinity, that's this way, what happens to the graph? It goes up, so y approaches positive infinity. Okay. because this is positive infinity for x, and y is going down, so that's negative infinity. This is negative infinity for x, and that's going up, so the value approaches positive. Okay, now I want to look at the next one. Okay, again, you have a higher power than a 2, so you're going to insert -3, -2, -1, 0, 1, 2. Okay, so 3, and I replace the -3 to the 4th, plus 4, -3 to the 3rd, caret 3, plus 3, parentheses, -3. Second power, you can just click that key. Plus 4, parentheses, -3, and then add 1. You get 151 for your output, okay? So click up, and now -3s now morph into -2s. Otherwise, this takes forever without this little function if you don't have this kind of calculator. That's why I told you guys all to use it. 21. Okay, then 1. -1. Now with the 0, you just look at the constant at the end. That's 1. Okay. Now you delete the negative, and that inserts 1 for you. Okay, 15. Okay, then I go over the 1s. 2s, and 101. Now I'm going to put 3s in. $391. Okay. Okay, so we're just going to graph this group right here. When it gets in the hundreds, I don't really want to graph it too bad, so I go left 2, then I'll go by 5s on the y-axis. 5, 10, 15, 20, 21, and be there. -1, -1, so I go left 1, and then I go up just a little, or down just a little ways, because we're going by 5s. 0, 1. I go up just a little ways from 0. 115, I go right 1, 5, 10, 15, 20. Now you have a kind of a parabola, but it's not really a parabola. It's not really going to be a classic parabola, but it kind of looks like that. Now, x approaches positive infinity. Positive infinity is over here. Now, what happens with the graph as you go that direction? It goes up, so y approaches positive infinity. Now, x is negative infinity. That's over here. And that side's going up as well. So, y approaches positive infinity on both sides. Now, fortunately for you, that's not your assignment. Okay? Now, here is the assignment. Write each polynomial in standard form and then classify it by degree and number of terms. Your highest power has to come first. Then x to the third minus x to the third. There's no x to the second. And then after x to the second, it's just your x term. Okay? So there you have it. Now, here's how you define the degree. The degree is the highest exponent, which is 4. The number of terms, you have 3. It's a degree 4 with 3 terms. Okay, the next one. The highest power I have is a to the third. So 3, a to the third, then a to the second. Now how about just a? I don't have any of those. Okay, and after I write them down, we'll cross them out. Then plus 1. Now it's in the right order. It's in standard form. The degree is a 3 this time because that's your highest exponent, and it's got 3 terms. Okay, now the next one, that's your highest exponent, so 12x to the fourth. There's no x to the thirds, there's no x to the seconds, there's no x's, there's just a constant of 3. Okay? So the degree is 4, and it has 2 terms. This is pretty easy. Okay, next page. This is a little bit weird. You have x to the third as your highest, but there's 3 of them. So we need to combine all of those by adding. We write x to the third down, but then we need to combine 7 minus 10 plus 1. That's going to give you negative 2. And now those, after you add them, you want to cross them out. Now there's nothing left over, okay? So it's a degree 3 because of the third power. And there's just 1 term. Okay, next one. The highest power is a 4. So I write x to the fourth. And it's actually negative 1. Okay, when you have a minus, it means it's negative. And that's the only one you have. You don't have any x to the thirds. X to the second, you got 2 of them. A 1x to the second and a 2. 1 plus 2 is 3. So plus 3x to the second. So when you first look at it, it looks like there's 3 terms, but it's not. It's a degree 4 because of the fourth power. But there only ends up being 2 terms because I have some like terms I need to combine. Okay, this one. X to the second is your highest degree, but you have 2 of them. So you combine the coefficients. 2 minus 10 is negative 8. So the degree is a 2 because of the second power, and you have just 1 term. Okay, pretty easy there. Now make sure you read directions. Now, determine the end behavior of each graph of the polynomial function. So instead of having to graph it, I just want you to tell you the end behaviors, what the arrows do at the ends. So here's how you set this up. You put x approaches, you write an arrow, and x approaches. Here positive infinity and here negative infinity. You're always going to write that. Comma, y approaches, y approaches. The arrow means approaches. Now, here's how you tell without having to graph it. Okay? As x approaches positive infinity, what does y do? That's determined by, first off, you need to write it in standard form, okay? The 6x to the second needs to come first, followed by the x, which is minus 3x, followed by the constant. Okay, here's how you determine the first one. It's all determined by your leading coefficient. Coefficient is spelled C-O-E F-F-I-C-I-E-N-T. The leading coefficient is 6. It's the front multiplier, and it's positive, so put positive. If your leading coefficient's positive, y is going to approach positive infinity on the positive infinity x side. Now, here's how you determine the other one, the degree. That's your highest exponent, is 2. Now next to 2, put whether 2 is even or odd. It's even. If we have an even, then y approaches the same thing from the other side. If it's odd, it does the opposite. Okay? And you'll see that. There's your answer. Next one, x approaches positive infinity. What does y do? What is y? What happens to the graph? As x approaches negative infinity, what happens to the graph? Okay. So the leading coefficient, you can just put leading, C-O-E, okay, abbreviation, is positive 8. So that means y approaches positive infinity. Now the degree is the highest exponent, which is 11. 11 is an odd number. So over here, y is going to do the opposite, which will approach negative infinity. Okay, first off, x approaches positive infinity, x approaches negative infinity. Y approaches, okay? Okay, now rewrite that so it's in standard form. X to the 8th is your highest. Negative 9x to the 8th. You don't have x to the 7th. You don't have x to the 6th. Minus 6x to the 5th. No x to the 4th, just minus 3 then. Okay, the leading coefficient, is negative 9. So this time it's a negative, okay? So that means the y is going to approach negative infinity as you move out here. It's going to go downward. Okay, degree is 8. 8 is an even number. Okay, so if we have an even number, the y approaches the same thing on this side as it does here. You don't make it opposite. If it's even, it'll do the same thing as this does. Okay, next one. Y equals negative 8x to the 7th plus 16x to the 6th plus 9. Okay, that's already good to go. Okay, I mean, you can rewrite it, but it's really not going to make any difference. I'm going to get a new pen here. So y equals, I mean, you already pretty much have it in order you want. X to the 7th plus 16x to the 6th plus the constant. Okay, so x approaches positive infinity, x approaches negative infinity. What does y approach? Meaning out here, what's going to happen? Leading coefficient is negative 8. So it's a negative. That means y will approach negative infinity. The degree is the 7th power. That's odd. So that y is going to do the opposite of what it does up here. So positive infinity. Okay, y approaches, x approaches. Positive infinity, x approaches negative infinity. This is how you define what's called end behavior of a graph. This is the end behavior, that's the end behavior. Okay, leading coefficient here is negative 1. It's a negative, so the y is going to approach negative infinity on that side. The degree is 3. Third power is your highest. Okay, 3 is an odd number, so that it's going to do the opposite, positive infinity. Okay, x approaches positive infinity, x approaches negative infinity. What does y approach? As that happens from each side, that's how it's expressed. Okay, rewrite that. 9x to the 10th is your highest. Then the next highest power is to the 7th. Then I have no more powers, just the constant of 5. Okay, the leading coefficient is 9, positive 9. Okay. So since you have positive 9 as your leading coefficient, you're going to approach positive infinity on that side. If the graph kept going in for infinity that way. Okay, degree. The degree is 10, which is even. So if it's even, it's going to do the same thing here as it does here. If it's odd, you switch it. Okay, and that's how you define the end behavior of the graph. Now, the next thing's really easy. Find the zeros of each function. Finding the zeros of a function means you replace the dependent variable with 0, and you just set each factor equal to 0. Okay? X minus 1 equals 0, x plus 2 equals 0. So I plus 1, x is 1. Minus 2, x is negative 2. How you write your answer is 1 comma negative 2. Okay, 0. Now you have to set the outside x equal to 0. and then x plus 5 equals 0, and x minus 8 equals 0. So you're already at 0 right there. So you got 0 minus 5, you get negative 5, plus 8, you get 8. Okay, next one. And then again, the zeros of the function means this variable all by itself is a 0. Fortunately, it's already factored, so we don't have to factor it. X equals negative 1, 1, and 2. Those are the zeros of the function. Eventually, you'll have to find them when it's not factored like that for you, but this is. Now you're doing the opposite way, okay? You get the zeros of the function, but now you have to write the equation, okay, in factored form. It's really not hard. You write y equals. Now, you have zeros of 5, 6, and 7. So you're going to make a parentheses, and you're going to put x minus 5. You start out with a minus. Another parentheses, x minus 6, and then x minus 7. Boom. Next one, y equals, parentheses, x minus 2, but there's 2 of the same 0, so you put to the second power then. And then parentheses, x minus 5. If you have to repeat 0, you make that one to the second power. Okay. Next one, y equals, parentheses, x minus, but if I see I have a negative, I switch it to plus 5. And then there's another identical 0, so it's to the second power, so I don't have to write it again. Parentheses, x minus, and then 1. Now, if one of the zeros is 0, you don't put that in parentheses, you just put x on the outside. Okay, you're not going to put a parentheses with x minus 0. That means you just put x outside. And then x minus 4, x minus, but if I see a negative, I go plus 6. Y equals x minus 1, x minus, but then if I have a negative 1, I go plus 1, and then x minus, and then I make it plus 2. Y equals, now instead of, I don't make parentheses for 0, okay? I put an outside x, but there's 2 of them, so it'd be x to the second. And then a parentheses, x minus 12. Now the last one. Remember, if you have 0, you don't put a parentheses, you just put x, outside x. It's the only one you have, so no power. X minus, and then 4. And the last one's kind of weird, okay? You write x minus. If it's negative, you're going to switch it to a plus 1/2. Now with fractions, here's what they want you to do. You cross out the 2 on the bottom and you apply it to the x as a multiplier. Because if you went 2x plus 1 equals 0, you'd subtract 1, divide by 2, which is negative 1/2.